Hopefully you've recently viewed my video that discusses probability distributions in general. Well, for the rest of this course, we're going to be discussing two specific types of distributions: a binomial probability distribution and a normal probability distribution. Today I want to concentrate on just a binomial probability distribution. Before we start doing any mathematics with it, I think we really need to make sure we understand exactly what is a binomial distribution and how do we know when we're dealing with one. That's a really good question. For example, let's say you decide to do a study with newborn babies. You go to a hospital, and here's your well-defined procedure. At the hospital, you go to the maternity ward, and looking through the windows at the various babies, you randomly choose, let's say, 7 of the newborns, and then make note of whether the 7 random that you chose were boy or girl. Okay? There's a situation. My question is, will that procedure, will it result in a binomial probability distribution? Well, to answer that question, we have 4 criteria that must be true. Let's make note of those 4. It's important to understand it. Let me come over here. Number 1, in order to have a true binomial distribution, you must first execute a fixed number of trials. And please recall that a trial is the action that's taken in a well-defined procedure, random procedure. Okay, and we normally represent the number of trials as the letter N. Okay? Number 2, the second thing that must be true is every one of these trials, every one of these N trials must be independent. And please recall what we mean by independent. That means the outcome of any one trial can have absolutely no effect on the outcome of any subsequent trials. Let's be independent. Number 3, this is the biggie. There must be exactly 2 different possible outcomes for each trial. Must be exactly 2 possible outcomes. Now, we give these outcomes names. We call them success and failure. And sometimes it's going to be pretty arbitrary which one we call success and failure. Sometimes it'll be obvious. Sometimes we have to make a decision. Really doesn't matter. All depends on what viewpoint you're taking. Okay, and number 4, the last absolute requirement in order to have a binomial distribution in my situation is that the probability of getting a success event, the probability of getting success, must be the same probability for every trial. The probability of success must be the same for each trial. Okay, there are the 4 requirements. Now, there's a 5th item I want to talk about, but I'll say that for a little bit later. These are the 4 requirements. The 5th item talks about exactly what the binomial distribution looks like. All right, let's go back to our procedure of checking out the newborns at a hospital. Let's take a look at it and see if that situation satisfies all four of these. Now remember, I specified we're going to randomly choose 7 newborns and see if they're male or female. Okay. First of all, do we have a fixed number of trials? Yes, we do. We said we were going to randomly choose 7. So I have 7 trials. And my trials are the random selection part. Okay? Number 2, every trial must be independent. The baby that I pick the first time, will it have any effect on what other babies I pick? No, shouldn't. So yeah, we can say that these trials are independent. There must be exactly 2 possible outcomes. Yeah, it's either a boy or a girl. Those are the 2. Now, here's a question. Which one should we consider success or which one failure? Should we consider getting a boy as being a successful outcome or getting a girl being successful? Kind of arbitrary, huh? Depending on your viewpoint. You'd have to pick one or the other and go with it. Okay? And number 4, the probability of success must be the same for each trial. Would you agree that we have a 50-50 chance, or it's so close to 50-50, we'll just call it that, of getting a boy or a girl? It turns out that getting a boy is just a tiny bit higher than 50%, getting a girl is just a tiny bit below 50%, but they're so close, we'll call it 50-50. So my situation as described about the hospital, indeed, does fit all 4 of these situations. So we can say that it is a probability distribution. Okay? Now let's talk about this 5th item. The way we set up our probability distribution, remember, is a table, very often shown as a table, with my x values here and my probabilities over here. Recall that the x value is the random variable, and in this case, for binomial distribution, the random variable x represents the number of successes out of n trials. X represents the number of successes out of n trials. And this is for each instance of performing my well-defined procedure. So, what that means is the different possible values for x are going to range from 0 up to n. Those are the different values to be. If we perform this procedure one time, in other words, go look at 7 different babies, 7 different newborns, it's possible, and let's say I define success as having a girl. Isn't it possible that none of them are girls? Okay. Is it possible that 3 of them are girls out of the 7? Sure. Is it possible that all 7 of them are girls? Yes, it's possible. So over here in this column, x would go 0, 1, 2, 3, and I'm not going to have room, but all the way down to 7.